Hey guys, what's going on? In today's video, I'm going to be showing you how to use Athena in AWS. What does this mean? I'm going to be showing you how to use a Lambda function to trigger some transformation, transforming your data in a readable format for Athena. Then I'm going to show you how to create a table in Athena based on these, what we call partitions. Now, partitions separate your files to make it read a smaller portion of the overall data. So if I separate my files in a folder path like year, month, date, and then I have my JSON object, which has a bunch of what we call rows in the table, we can go ahead and just look at that single day out of the year and look at that small bit of data. So far we've created an API gateway, which triggers Kinesis and writes to S3. Today we're looking at creating a Lambda function triggered by S3, which goes ahead, transforms our data, and writes back to S3, which then Athena can use to query from. The reason I'm using a Lambda function here rather than something like Glue with crawlers and an ETL is because we're actually making an API call, or I'll make an API call to Google Places to label our data with the name of the place based on the location. In later videos, you'll see we'll use CloudWatch events to trigger Lambda functions to do Athena jobs and write those results into an S3 bucket. So let's get started. So I've gone ahead and made something that actually uploads like mass amounts of data to our API, and that will be sent to S3. So let's go ahead, open up a new window, and we need S3 to trigger Lambda anytime a file is uploaded. So let's go ahead over to Lambda. We're going to go ahead and create a new Lambda function from scratch. We're going to call it S3 trigger visitation. We're going to run this in Python 3.7, and we're going to create a new role with basic permissions and create function. All right, so our Lambda function has been created. However, because we're writing to S3, we're actually going to need permissions here, and we're also going to need the trigger, meaning that when data gets written to S3, when it gets batch uploaded to S3 from Kinesis Firehose, that's going to go ahead and trigger this function. So select a trigger. We're going to go ahead and look for S3. Okay, and we're going to go ahead and choose our bucket, which, if you stuck with us, is going to be our event type data. And that's going to be all object create events and enable trigger add. Okay, now we're going to go to our IAM. So let's go ahead and open up AWS console, and we're going to need to modify that role to add a policy to write to S3. So let's go and open up our console, go over to IAM. We're going to go and find the role we just created with our Lambda. And there it is, S3 trigger visitation role. And we're going to attach policies, and I'm just going to go ahead and give it S3 full access. There we go, and attach policy. Okay, so now we have the ability to write to a new S3 bucket. So let's go ahead and actually write our function. Go ahead and erase the to-do statement. And here I'm actually going to write in what my function is for getting name of place. And so this is going to go ahead and take in a lat long, and it's actually going to return a string of the name of the place based on the Google Places results. So I'm also, for this reason, going to go ahead and import URL library.request. And I'm going to skip through this. If you want to see what's going on here, I'll go ahead and post a link down below to my GitHub. Otherwise, I'm going to write this real quick and skip on through it. All right. Okay, so there it is. And now in order to write to S3, we're actually going to use Photo Core and Photo 3, as we've probably used before. So let's go ahead and import Photo 3. We're also going to need to read a gzipped file. So let's go ahead and import bytes IO, and we're also going to import gzip. The last thing we're going to import here is date time, because we will name our file based on the current time, thus creating unique keys. Okay, so now we need to get the actual S3 file name based on the event. So the event that's been triggered is based on our S3 bucket. And so it's going to tell us the file name in the S3 bucket to read from and format, and then we will write that to a different S3 bucket. So let's go ahead and create S3 equals photo3 dot client S3. And we're going to check if the event exists. And if so, we're going to go ahead and find our file name and our file object and actually read that file data. So that's going to be under our event records. And that's going to be the first one that appears. And we're going to go ahead and get the file name. And that's going to be our file object, S3, and key. And if you go ahead and print out your event, you'll see this is all just one big nested dictionary. And you're going to iterate through it like so in order to get the file name. Okay, now let's go ahead and actually get our file object from our S3 bucket now that we know the name of the file. So S3.get object, and we're going to specify our bucket as event pipe data, and that's just coming from previous videos. That's what we've named our bucket. And our key is now going to be our file name. Okay, we're now going to get the byte stream data from our body of the file object, so bytes.io. File object, go ahead and get the body of it, and we're going to go ahead and read that. Now to get the actual content, we need to unzip our file. And our file object is byte stream. Let's go ahead and we're going to read that and decode it in UTF-8. So if you print your file content, you'll actually be able to see the file content. Because of the way that we've specified for Kinesis to batch data every 60 seconds or based on a certain file size, it goes ahead and it takes that data that we specified to our API, which is a list of JSONs, and it goes ahead and it appends one list, and then it goes and prints the other list down below it. So it's going to look something like this with multiple JSON objects, and then right below it, you'll have another list. So in order to get rid of this, and in order to read all of this together, we're going to format it so that we can make it look like this. And then we can read it in as a JSON object. So in order to do this, we're going to go ahead and we will replace those back-to-back lists with just a comma, and it will just continue the beginning list. Then we can go ahead and we can nicely read in our JSON now. So let's go ahead and say data equals JSON.loads of file content. Okay, now we have the actual data in our S3 file in a JSON format. So now it's in a dictionary. And we're going to prepare first our file output, because as we loop through, we're going to go ahead and write to our file. So for our file output, we're going to base this on the current date time. So let's go ahead and get that and say now equals datetime dot now. And also getting this datetime is going to go ahead and help us with our file partitioning. And I'm going to go ahead and make it in a format acceptable for file names. So getting rid of these spaces and replacing them with underscores. I'm going to go ahead and get the string of the year. Same with the month. So I'm going to partition here by year, month, and day, which is where these are going to come in. And then we're going to need our bucket name to write to. So I'm going to go ahead and call that visitation-labeled. And let's go ahead right now and just make that bucket. Let's go over to S3, create a bucket, and we're going to create bucket name visitation-labeled. And I'm just going to go ahead, next, and create bucket. There you go. So going back to our Lambda, now we have that bucket created. So now we're going to go ahead and create the actual file name to be written to this bucket. So file name, I'm going to say equals now string dot replace, and I'm just going to go ahead and format it so that it looks a little nicer. And I'm just going to go ahead and do that again, replacing colons, replacing dashes, and periods to make it a little more readable. Okay, and our file name is going to be in JSON format. So Athena actually just goes ahead and reads JSON however the JSON has to be in the right format, which I will get to once we start writing our actual file, writing to our file. So we're going to specify our Lambda path, which is going to be where data is written to temporarily until we upload that file to S3. So we're going to say /temp/ and go ahead and get our file name. We're now going to set our S3 path. So this includes all subdirectories, directories before our file. This is how we partition it. So in order to partition, you're going to need to say the column you want to partition by equals, and then whatever the value of that partition is. For example, since I'm partitioning by the year, month, and day, I'm going to go ahead and say year equals, and I'm going to include the year, add a slash, go ahead and include month equals, another slash, and the final partition is going to be day. Oh, and it looks like I actually forgot month here. And day equals day. And then we're going to go ahead and actually have our file name. Okay, so now we need to write our file and massage it for Athena purposes. So let's go ahead and open that Lambda path, so that temp file. And we're going to write to it. And we're going to go ahead and call the file F. And since our data is actually just a list of JSON, or of dictionaries in this case, we can go ahead and say for point in data. And what I'm going to do is, like I said earlier, I created this function to get the name of the place based on the lat long. I'm going to go ahead and make this API call. Again, this is why we're doing this in Lambda and not BTL and glue crawlers. And I'm going to say name equals get name of place. And I'm just going to access the latitude and longitude of the point. And then I'm going to go ahead and set our name in the dictionary for each point. Okay, and one other thing I need to massage our data is to reformat this datetime string that I've read in from Swift, which kind of has a funky format. So I'm going to go ahead and take off a little +000 at the end, which indicates the milliseconds. So I'm going to say point arrival. We have arrival and departure, and I'm just going to go ahead and split them up and then take off the last part of it. Okay, and I'm just going to go ahead and do the same thing for our departure. And now we actually need to go ahead and write this point to the file. So f.write, and we're going to go ahead and dump this one single JSON, this one single point individually so that we can go ahead and format it for Athena, which needs each JSON object on its own individual line, split only by a new line character, so no commas, and nothing encapsulating all of the JSON objects. So let's go ahead and say f.write json.dumps and point. And then we're going to go ahead and write this new line. Okay, so now we have our data in the correct format, but in a temporary storage in Lambda. So let's go ahead and move that using Boto3 to our S3 bucket. So s3.upload file. And we're going to go ahead and specify our Lambda path, our bucket name, and our S3 path. Okay, so now that we have this all written too, I'm going to go ahead and test it. But rather than the ways that I've tested it previously, like going into Swift and simulating a location and making the person sit in a certain place for a couple minutes, I'm going to actually just send a bunch of data to our API, watch it hit our S3 bucket, trigger the Lambda function, get reformatted, and dumped back into an S3 bucket in the right partition data format. So I've gone ahead and built a different Lambda function, which does just that. And I will put this on GitHub as well. And I'm just going to go ahead and hit test. And that's going to go ahead and trigger API to Kinesis Firehose into S3. It might take 60 seconds due to our batch time. If you want, you can try it multiple times just so you can kind of see how it actually does batch these in multiple lists, but back to back, so you can replace that one little funky character and turn it into one large list. Okay, so if you did exactly what I did, you'll see that our data actually appeared in our event pipe data, but did not appear in our visitation labeled. So that means something went wrong with our Lambda function. In order to debug Lambda functions when they get triggered, you're going to want to go ahead and open up a new console, and you're going to want to go ahead to CloudWatch. So if we go ahead and type in CloudWatch, and if you go over to CloudWatch logs, you can actually see your Lambda function, which is S3 trigger visitation. And here we see it ran, but it reports an error. Now the error is that S3 key doesn't exist. And that's on me. I'm going to go ahead and fix that. I actually meant to type S3 object key. So go ahead and save that. So now if we go ahead and run this test again, we should see our data upload, the Lambda trigger, and our data will arrive in our labeled visitation bucket. I'm going to go ahead and test by making a put request to the API. All right, so after running it again, we see that the duration of our Lambda function actually timed out. So if we go over to our Lambda function, we'll notice if we scroll down that our basic settings have a timeout of 3 seconds. Now we're going to need a little more time, or at least for accessing this API, than 3 seconds. So I'm going to go ahead and change this to 1 minute. We're going to run it again, and this time it will go ahead and execute properly. All right, so opening up S3, there we go. We finally have it. Our year equals 2019, month equals 8, and day equals 13. And there is our JSON file ready for Athena. So let's go ahead, open up a new tab, over to our AWS console, and we're actually going to open up Athena. So go ahead over to services, and we're going to search Athena. Now in Athena, we're going to create let's go ahead and exit out these previous queries. We're going to go ahead and create a new table, create table from an S3 bucket. We're going to create the name, which I'm going to call SDK data, and I'm going to name my table visitations. Now we need the location of our input set. So we're going to go ahead and specify s3 // and this is going to be your bucket name. So our bucket name is visitation labeled. Okay, so go ahead and hit next. Our format is in JSON. And now we need our column names. So column names, we have arrival. And I'm just going to skip through this, but you can imagine you specify your column name of each type. You go ahead and hit next, and you do not have to worry about including your partitions here. All right, so there we go. We have all of our columns selected with the type. I'm going to go ahead and hit next, and we can go ahead and configure our partition. So add a partition. Our first one is year, and that's going to be an int. Adding another partition, we have our month. And our last partition is day. And we can go ahead and create our table. So there you go, create external table if not exists, SDK data.visitations, each column with its type partitioned by year, month, day, formatted here in JSON, and specifies our location. So there our query has ran and our table shows up here, partitioned on the side. So now that our table's been created, Athena actually needs to know where the data is based on the partitions. And even when you upload a new partition or a new day that wasn't in there before, a folder for the day that wasn't in there before, you need to go ahead and you need to repair your table, which means now Athena can see that the data in those folders or in those partitions exists. So if you go ahead and you make a new query, you're going to type in msck repair table and type your table name. And when you run it, it will show any new partition folders that have been added. Now you can select your data and it will appear. Previously, nothing would have appeared and it would have showed 0 records returned. All right, so there it is. We've gone ahead and returned all the rows in our table, all 10 of them from our test Lambda earlier. And that is all for today's video. So what have we done so far? In this video, we have learned how to trigger an S3 Lambda, which goes ahead and massages and transforms your data. It went ahead and also made an API call. Again, you could have used a glue ETL and glue crawlers to do the same function. If you didn't need that API call, then we went ahead and we created it into JSON formatting that Athena accepts. And then we've gone ahead and created our table through Athena, which we can now query using the query editor. In later videos, I'll show you how to use AWS Lambda to actually schedule your functions that trigger your Athena queries and store your results. So that's all for today. If you enjoyed it, go ahead and like and subscribe. I will see you next time.